Thank you and good evening, Crosby Ramblers. Yes, this is a ramble through the night sky. A fairly gentle stroll, or perhaps a ramble, and we'll be taking a break after a few minutes. It's not going to be too deep. There's a little bit of science in there, but don't worry, if the science isn't your bag, then just take a few minutes of a nap and then come back again afterwards. So I'll be asking what's up there in the night sky? How can I find my way around? What if I want to see more? What if simply glancing at the night sky is not what you want to do? I gather you are not a group of astronomers, but maybe there's a nascent interest in there somewhere. And I'll be answering the question, how can I take photos? Because this evening, it's really an excuse for me to show some of my photos of the night sky, the objects that are out there, the stars, the clouds of gas, the galaxies, etc., that are out there in the universe. I've taken a lot of photos over the years, and I'm going to show some of them to you this evening. So note that I am not attempting to tell you everything about astronomy. I am not attempting to tell you everything that there is up there. No way can we get that into one evening. So it's really just a random walk through the universe. I'll be saying a little bit about how amateur astronomers do their stuff when they look at the night sky and when they try taking photos of the night sky. And it is very random in the sense that it's difficult to get it structured within something that's only 45 minutes or so long. I'll just be dipping into various aspects, and I welcome any questions at the end about wanting to know more. And I'll be recording this talk, and I have handouts of the slides of the talk. If anybody is interested, I can talk to you afterwards about how you might get more involved in astronomy. So along the way, talking about how we think about the way the universe works, I'll be showing photographs that I've taken. Some of them were taken...
I've just had a request for the people at the back. Could you possibly read out what's on the screen? Because some people can't see it.
Would it help to have the slides?
Yeah.
Yep. I mean, how many people would like them? So along the way, I will be showing photographs that I've taken with a telescope and without a telescope. So don't be fooled into thinking, if you're interested in astronomy and you're interested in what's in the night sky, don't be fooled into thinking that you absolutely need a telescope. A lot of what I've done, a lot of the photographs that I'm going to show this evening were not taken with a telescope. I'll make it clear along the way, hopefully. So let's start with what's up there. Our favorite neighbor, the moon. We seem to have a few extra stars. Those are nothing to do with my presentation. These are just dots on the projector. So it looks like we're going to have those same dots on every image, which perhaps could get a little bit confusing after a while. But here we have our neighbor. I mean, perhaps you realize that stars should not be visible on this side, the darker side, the unlit, the shadow side of the moon. There should be no stars visible on there because we're just looking at the unlit side of the moon. So even our closest neighbor, the moon, can be fascinating. Just watching the shadows of the craters and the mountains change from night to night. You know that the phase of the moon changes. That's the angle of the sun hitting the moon. And so the detail you see in craters and mountains, okay, the detail you see in craters and mountains on the surface of the moon change from night to night. And so with either binoculars or a small telescope, you can see various bits of detail on the moon, and it can be fascinating. Yes, the features themselves don't change, but their appearance changes simply because the angle at which the sun hits the moon. I've got an orrery at the front here, which you're welcome to come and take a closer look at, either in the break or afterwards, which is a model of the solar system reminding us about the planets in the solar system. But bear in mind, when you go out into the night sky and have a look, the planets will show up as bright points of light, but they are so far away and so small, you can't really see any detail, even with binoculars. You do need a small telescope. And even in a small telescope, the planets can sometimes be a little bit disappointing. If we're used to seeing the wonderful images from the Hubble Space Telescope or the images from spacecraft that have visited those planets, then to see a very small little dot of light in a telescope, in a small telescope, perhaps can be a little bit disappointing. So sometimes we get interesting visitors to the solar system, like comets. This is obviously a very old slide talking about a comet from many, many years ago. Unfortunately, there are no comets around at the moment. If we wanted to have a look again at Jupiter, ignore the stars in the background. These are not moons of Jupiter, they're just dots on the projector. You can actually see in a small telescope, you can actually see some detail on Jupiter. Perhaps you can see the bands there, the belts of Jupiter. And that's about all you can see in a small telescope. You'd have to pay many thousands of pounds on a telescope to get a much more detailed view of Jupiter. And even though we can't see a lot of detail, it can still be absolutely wonderful to get a view of Saturn, because you can see the rings, you can see a shadow of the planet on the rings themselves. Even in a relatively modest-sized telescope, it is a wonderful sight to be able to see Saturn. Yes, not a huge amount of detail, but you can see it's a ringed planet. And to show youngsters a view of Saturn through a telescope, almost regardless of what size the telescope and almost what size the child, they can be fascinated by seeing Saturn for themselves. And that's what turns a lot of people onto astronomy in their earlier days. So, with a modest piece of equipment, it's difficult to see detail on planets. So we can move beyond the solar system and say, what else is out there? What else can we possibly see with binoculars or our naked eye? And what can we photograph? If you go out on a dark night and get away from street lights, hopefully you will see the Milky Way crossing the sky. Not particularly well placed at the moment. The Milky Way is relatively low on the horizon, but a little bit later in the year, towards the summer, the Milky Way arcs across the sky from one horizon to the other. The Milky Way is the collected light of all of the stars in our own Milky Way galaxy. So yes, we have individual stars that are relatively close to us and show up as the stars in the night sky, of which we can see, if you're really lucky and you get away from light pollution, you might see 1,000 stars in the sky. Perhaps you think you can see more, but probably not. 1,000 is actually quite a large number. But there are more stars in the Milky Way galaxy. The Milky Way galaxy contains not thousands, but hundreds of billions of stars, and they are usually so far away, they merge together in this band of light. And here's the band of light streaking across the image from the top left to the bottom right. The Milky Way itself has got a large number of stars and quite a bit of dust. And in this image I took a few years ago, I've particularly processed it in a way that brings out the dust. Let me just make it a little bit larger so you can see it perhaps a little more clearly. So we have huge numbers of stars in the background, and we have dust that's part of our Milky Way galaxy. If I scan over to the right, the very bright star there is not a star, that's actually Jupiter, an interloper that happened to be in the same field of view. But if we look over to the right, we see a very colorful area. There's blues and oranges and reds in there. And I'll blow that up in just a minute. Let me just zoom back out for a second and remind ourselves this is a relatively large chunk of sky. Again, not taken with a telescope. This is a wide-angle view of the sky. This is taken with a camera and a wide-angle lens. So we are literally looking at a fairly large chunk of sky here. If I label a few bits and pieces, again, I know you're not astronomers, so some of these labels won't mean much to you, but within the Milky Way, we see these small splodges, which are clouds. They are clouds of hydrogen. They are called nebulae when we are looking at clouds in the astronomical sense, rather than clouds here on Earth. So there are lots of these clouds of hydrogen, and most of these are star-forming regions. This is where stars are being born all the time. Notice that occasionally we draw lines between the stars because that helps us to find our way around the sky. We have familiar constellations. Perhaps you know about the Plough. Perhaps you know about the constellation of Orion. There's lots of patterns in the sky, and astronomers, especially amateur astronomers, use those patterns to help them find their way around the sky. So for instance, if I want to know where the Lagoon Nebula is, I simply remind myself, oh, it's just above the pouring spout of the teapot. It's an easy way of just navigating your way around a sky. A sky is not just a random collection of dots to an astronomer, it's a particular set of patterns. Much like the patterns of where cities are located in the United Kingdom is something that you've got a mental map of. Same idea for astronomers and the night sky. But if we return to this rather colourful patch up here in the top right, again, these are clouds, nebulae, and this is one of the closest star-forming regions to us. In other words, this is where stars are being born. And on the cosmic scale, on the galactic scale, this is relatively close. This is the closest star-forming region to us. And therefore, you don't need a telescope in order to go and look and see more detail there. This, remember, the picture you're looking at is a wide-angle lens. I've also tried photographing the night sky not with a wide-angle lens, but with a telephoto lens to get a smaller field of view. And that rectangle up in the top right there is a field of view that I took, and I did a long exposure of that particular patch of sky, and this is what resulted. It is a beautiful part of the sky. It is a cloud of hydrogen, part of which is being lit up on the left-hand side by a big red star, making the cloud look yellowish or orangey. There's a very blue star over on the right-hand side, and that is reflecting a lot of light, causing the nebula on the right-hand side to have this beautiful color, blue. So these colors are natural colors. They're not artificial colors produced by the camera. They're not artificial produced by me, deliberately making things look colored. These are the actual colors of the night sky. It's difficult to see these colors with the naked eye because our eyes are not well suited to seeing color when the lights get low, but the colors are genuine. Notice that some regions, these ghostly regions in the middle there, seem to be these dark clouds. Well, they're probably made of much the same stuff as everything else, a little bit of dust mixed into the gases that exist across the entire Milky Way galaxy. But these are not being illuminated by any stars, and so they're blocking out the light from anything that's behind them, so they tend to look dark. So whether a nebula is bright and glowing or whether a nebula is dark really just depends on whether there are any stars nearby and what is behind those nebulae. Fundamentally, they are made of the same stuff. But this is just a reminder that an ordinary camera, this is my digital SLR camera, the one I use for taking pictures during daylight, the one I take pictures of if I go and do some wildlife photography. It's the same camera I use for daylight photography, in this case, pointed at the sky to take these images. It's not a special camera. It's not an astronomical camera. It's not taken with a telescope. It's taken with a camera and lens, and I'll show you how we do that a little later. But this is not our Milky Way galaxy, but our Milky Way galaxy almost certainly looks like this. This is our immediate neighbor, the Andromeda galaxy. If we were to go to the Andromeda galaxy and look back at our galaxy, it would look pretty much the same. So this is, in galactic terms, in terms of galaxies that are out there, this again is our immediate neighbor. And our immediate neighbor in this context means millions of light years. A light year is how long the distance that it takes light to travel 1 year. So in other words, light has been traveling from this galaxy to reach the camera to make this image. That light has been traveling for 2 million years. The light left the galaxy 2 million years ago, has been traveling ever since, and then I opened the camera shutter and took this image. This particular galaxy has got a couple of small satellites, these blobs here, just to the left of center and bottom right. Those aren't smudges, those aren't thumbprints. They are genuine small galaxies that are orbiting this rather larger one. And you can see the structure of the galaxy. It's a spiral structure, not seen face on, but seen at a jaunty angle. But you can see the structure, the spiral structure of this galaxy. And we think that's pretty much what our Milky Way would look like if we were able to move outside the Milky Way rather than see it from the inside. So we've left our own galaxy in the sense that we're now looking at other galaxies, which used to be called island universes when we weren't sure exactly what they were, but we now know those are galaxies in their own right. But if you wanted to see what's out there in the night sky, you're not limited by going only 2 million light years. That's the most distant object you can see with the naked eye, probably. Those that have reasonable eyesight can see this galaxy with the naked eye up in the constellation of Andromeda. It's not visible at the moment, it's the wrong time of year, but in a few months' time, when Pegasus and Andromeda start to rise over the eastern horizon, that galaxy will be visible to the naked eye, pretty much just as a smudge. But with a camera and a telephoto lens, you can get some very nice images of it. But that's not the limit to how far you can go photographing the night sky. There are lots of galaxies out there. This one, beautiful structure, you can see the individual arms. It's because this galaxy is so close, you can see that structure. With other galaxies, they are more distant, so it's much more difficult to see the structure in, for instance, this group of galaxies. Here, each of these splodges, each of the things that is quite definitely not a dot, so we have to separate the individual stars from the individual pixels of the projector, but anything that is a smudge is quite definitely a galaxy. Not necessarily the same size as the Andromeda galaxy, but probably containing hundreds of billions of stars. And we've now got a pretty good idea that most of those stars will probably have planets going around them, so the number of planets out there is absolutely mind-boggling. These are small because they're distant. They might be a similar size to the Andromeda galaxy. It was taken with the same lens as the previous image. These are smaller because they are more distant. They are not 2 million light years away. This particular collection is probably 50 million light years away. So the light has been traveling from these galaxies roughly since we had dinosaurs roaming the Earth. This is something you have to get used to when you don't have to get used to. This is something that astronomers get used to when they're thinking about things that are very distant. Because light takes a finite length of time to go anywhere, the further in terms of distance you are looking, the further back in time you are looking. You're looking at these galaxies as they were 50 million years ago, because that's when the light left them. And the more distant object you look at, the further back in time you are looking. When you look at the moon, you're looking at it as it was 1 second ago. When you look at distant planets, you're looking at them as they were hours ago. But when you change gear to looking at stars and galaxies, you change from seconds and minutes to years and millions of years, and actually even further. So for those that don't like science and don't like having their minds blown, just avert your gaze just for a couple of minutes. During lockdown, when I couldn't go to the pub with my friends, I asked the question, I wonder how far I can actually see with my camera. I'm limited as to how far I can see with my eyes. The Andromeda galaxy is pretty much the limit. But I wonder how far I could possibly see if I put my camera and pointed it at a patch of sky. I'll come back to what this box is shortly. But because the Earth is turning, if we take a long exposure of the sky, everything will blur unless you move the camera to follow the stars. That's why we have basically a motor in a box. So there's my Nikon camera sitting on this box, and I photographed an object, not the bright point in the middle here. That was just a star that happened to be in the same sort of ballpark of sky. I was interested in an object that I knew should be at the center of this image. And those red lines, if you can see the red lines, show you the object in question. So it's that tiny little splodge there, which is barely bigger than a pixel. It is a very, 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 very remote galaxy. And it's called a quasar because it's a type of galaxy that has a very bright nucleus and emits quite a lot of light. So don't worry about quasar, treat it as just another galaxy. But if I blow it up, you can see that there's virtually nothing there. It's barely a pixel in my image. But the distance of this object is absolutely mind-bending. It's not thousands of light years, it's not millions of light years. 25 billion light years away. Remember, the Earth isn't even that old. The Earth is only 5 billion years old. The light that produced this image has been traveling for more than 12 billion years. The Earth is only about 4.5 billion years old. So the light that produced that little splodge left this object long, 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 long before the Earth even existed. It was traveling through the universe for billions of years before the Earth came into existence. And then the light continued to travel on. Eventually, it came into the Milky Way. Eventually, it came into our solar system. Eventually, it arrived at Earth. It dodged a few clouds, entered my camera, and produced that little splodge. And that was on a warm summer evening in July 2020, when I couldn't do anything else more interesting. But it proves that it is possible with an ordinary camera, not a camera that's been modified for astrophotography. It's not been modified, it's not been adapted, it's not been bought specially for this purpose. It's the camera I had anyway that I used to take pictures of animals, and it's able to take a picture of a galaxy far, far away. Billions of years old, effectively. Not even sure that galaxy is still there because we're photographing it as it was 12 billion years ago. So, sorry about digressing into science. I just find it fascinating that not only can you take very nice, colorful pictures of the sky and get all those wonderful blues and yellows in a nebula, you can also photograph galaxies that are mind-bending distances away. But if you were interested in astronomy, if you did want to find your way around the night sky, how would you possibly do that? It's all very well me saying I can do that because I've been interested in astronomy for decades. But if you were interested in finding your way around the night sky, well, in my day, you used to buy a sky atlas. These days, why would you buy a sky atlas when you can get an app for that? So you can get various types of apps that you can put on your phone or put on your tablet, and they help you find your way around the sky. You can use them, for instance, for learning what the constellations are. This pattern of stars appears in the north, and that's what we call Ursa Major, or the Plough. And this pattern of stars is Orion, and that appears in the winter, etc. And you can learn your way around the sky by getting these apps and using them. Some of them, most of them, in fact, have devices inside the app that will basically work out which way the phone is being held and will show you the patch of sky that you are pointing at because the phone knows which way up it is. And so you can effectively say, well, what's that bright object over there? And it will say, well, that bright object over there is Jupiter, because it knows the time, it knows where you are, and it knows which way you're pointing. So yes, I know you can't see all the detail there. Let me make it a little bit bigger. But if you wanted to, these apps here shown on a desktop computer, a little bit more tricky to see if you've only got a tiny screen on your phone. But basically, you can say, show me the sky tonight. This is where I live. I want this month, this time. Show me what the sky is if I'm looking south, and it will say, this is what the sky will look like. The Milky Way will be running across there, and these are the names of the stars. I appreciate you can't read the names, but these are the names of the stars that you are currently looking at if you're looking south on this particular day. Some of these stars have very simple names, like Altair, for instance, or Antares. Some of them have rather more difficult names, like Zuban el-Janubi, which comes from the Arabic. A lot of star names are Arabic, and a lot of them begin with A in the alphabet. But you don't have to learn them all. This will tell you what it is you're looking at, which constellation, which star. That bright object over there is a planet. A comet has appeared at this part of the sky, etc. It will also tell you something about the planets as well. It's very difficult, very expensive to get a telescope that will show you that amount of detail on Saturn. But if you wish, these apps will show you what you would see if you had a telescope. At the moment, if you zoom into Saturn, it'll say, there's Saturn. And again, apologies for the extra dots. Each dot here should be a moon of Saturn. The ones that are labeled are the moons. The ones that are unlabeled are the pixels on the projector. So yes, we have moons of Saturn, and so if you were lucky enough to get a small telescope and look at Saturn, and you say, there's a little dot next to Saturn, what's that? The app will tell you the little dot you're looking at is the moon Titan, for instance, or whatever it happens to be. So the apps are relatively friendly, and because they will tell you what's in the sky now and what it is over there, they basically help guide you around the sky without any specialist knowledge. What if I want to see more than I can see with, well, just by walking outside? I think this perhaps would be a good time to take a break and have a quick cup of tea. Thank you. Okay, welcome back from the tea break. I finished by saying, what if I want to see some more? If I go out into a dark sky and think, this is fantastic, I can see all these wonderful things, well, what would I have to do in order to see further or see more? Well, one option is to buy a telescope. And it depends on how deep your pockets are, which telescope you might want to buy. That's a relatively arbitrary range there, from a few hundred to tens of thousands of pounds. And it is very, very confusing. Because if you look at, I'm interested in buying a telescope, which one should I buy? You have a choice of thousands, all different in terms of their specification. It's virtually the same as asking, what car should I buy? What is the best car? No such thing. Depends what you want the car for. So a lot of people will get into astronomy, decide to buy a small telescope, after a while realize, well, maybe it's not that good, I'll go for a bigger one or a better one, or trade off or get second-hand, or join an astronomical society and then find out what other telescopes other people are using, and it is a bit of a minefield. Don't bother about reading all the detail here. I tried to help people by trying to map out how expensive telescopes were. Now, admittedly, this is a few years old. For some reason I don't understand, they haven't got much more expensive. Probably means they were very expensive in the first place back in 2021, but the last few years, despite a little bit of inflation, doesn't seem to have bumped the prices up that much. Thank you very much. All this particular map is supposed to be telling you is that if you've got hundreds of pounds to spare, well, you can buy different telescopes. I'm not going to go through the details of why these telescopes are all different, but the telescopes, as you get to larger and larger and larger telescopes, not surprisingly, you have to pay more and more and more. If you've only got a few tens of pounds, then the advice normally is don't buy a cheap telescope. It'll be rubbish. You're far better off to get a pair of binoculars. That will allow you to see detail on the surface of the moon. It'll allow you to see the moons of Jupiter, for instance, as long as you hold those binoculars steady. Only if you've got, let's say, for the sake of argument, more than £100, should you consider buying the smallest of telescopes. And then, well, there's really no limit to how much you can spend. The arrows on the right-hand side remind you that this is not an upper limit. £700 is not an upper limit. Some people get very enthusiastic about their hobby and literally will spend thousands, if not tens of thousands, on their hobby. If you have the slightest interest in getting into astronomy and buying a telescope, don't until you've talked to somebody who knows what they're doing. I've got a talk about how you go about deciding what telescope to buy. If anybody has an interest, I'll gladly answer by email any questions you've got, but don't rush into these things. Don't spend hundreds of pounds when you don't quite know what you're doing. I'll gladly advise anybody if they want to email me. If you did decide to buy a telescope, well, are you going to keep it indoors and take it out into the garden whenever you need it? Well, that's one option. I prefer to think that's the sort of observatory I want. Look at that, a fantastic dome. This is in California, the Hale telescope, the largest telescope in the world when I was born, the largest telescope in the world for all of my childhood, and the largest telescope in the world for most of my adult life. This was me visiting it in 1982. I think I've got longer hair there. Might have changed my shirt, you never know. But this was me visiting this thinking, when I grow up, I'm going to have a house with a back garden big enough for an observatory like that. I had to downsize my aspirations and ended up buying a shed from B&Q. And basically, perhaps you noticed that it hasn't got a roof. It's got a shower cap on the top, like a trailer cover. And that comes off to reveal the sky and allows me to do some observing. That unfortunately has rotted through because this is, as you can see from the date there, nearly 30 years ago. You can tell this is a very old picture for a number of different reasons, either the design of the telescope or the huge, thick laptop compared to the thin laptops we have these days. But actually you can tell it's an old picture because the shed is clean and there's no spiders. Basically, they very quickly take hold of these things. Every once in a while, we take our students. I'm from the University of Liverpool. Our sister organisation is the Liverpool John Moores University, and jointly we teach an astrophysics degree. Physics and astronomy, as well as astrophysics. So for our students that want to know what it's like to observe from a proper dark sky site, we take them to Tenerife. And on that caldera there, blown up in the inset, are the observatories that are sitting on the top there at Teide Observatory. We take them there because they can't really do any serious observing from Liverpool. There's just too much light pollution, too many artificial lights, street lights, office lights, etc. If we go to Teide Observatory, yes, there's often cloud around, but the observatory is above the clouds. Basically, to get to the observatory, you drive through the cloud bank, and then you look down on the clouds and feel sorry for all those people down on the beach who aren't getting the sunshine. So you get about 10 hours of nighttime, and basically the conditions are really good up there. And we take students there for a field trip in the summer to teach them not the physics, because they learn the physics whilst they're at Liverpool. We teach them the hands-on, how to point a telescope at the sky, how to take an image of a galaxy. This is a relatively long exposure of quite a few seconds, so the telescope doesn't appear to be moving, but the student looks very ghostly on the right-hand side because they are moving during the exposure. Our students don't look that fuzzy, usually. It's only these images. So that gives you an idea of the size of telescope that they use. It's many meters high, weighs half a ton or so, and it gives them an idea of how real telescopes work. If and when they ever become professional astronomers, they'll end up using computerized telescopes, but this teaches them the basics by giving them a week on a telescope that they can control manually. If you were interested in not simply looking up and saying, ooh, stars, if you wanted to take photos, yes, a little bit of expertise does help, but I reiterate, you do not need to spend huge amounts of money. You don't need to spend tens of thousands or even thousands of pounds on telescopes if you're interested in photographing the night sky. This is simply the camera put onto a tripod and pointed into the sky. This is when I was on holiday visiting the pyramids of Egypt and then went into the neighboring country of Jordan. This is the night sky, photographed for about 5 minutes or so. One star doesn't appear to move. That's the star Polaris, the North Star, because the Earth's axis points towards that star. So as the Earth rotates, that star doesn't appear to move, but all the other stars appear to rotate around Polaris. With a longer exposure, it's a little more obvious. So again, here's an exposure taken whilst we were on a field trip. And there is the star Polaris that doesn't appear to move. All the other stars, as the Earth rotates, all the other stars will appear to rotate around Polaris. Of course, one rotation in one day, because that's the rotation period of the Earth. So even a few minutes, the stars will start to move. Even a few seconds, the stars will start to move. You don't notice the sky rotating. If you walk outside and look up for just a few seconds, you don't notice that the sky is rotating. You can't feel the Earth rotating under your feet. And it's only if you stare at something, for instance, like the moon for a few minutes, that you notice the moon is actually moving very slowly because the entire sky is rotating. So if you want to take an image of a star, or essentially anything, a star, a nebula, a planet, a galaxy, a collection of galaxies, you basically have to compensate for the fact that the Earth is rotating. If you don't, you'll end up with star trails. If that's what you want, great. Aesthetically, they can be beautiful, especially if you take long exposures. There's a 6-hour exposure. You can tell it's 6 hours because the stars have trailed approximately 1/4 of a rotation. So here I plonked the camera outside, told the camera to keep taking pictures, and then added them all up after about 6 hours or so. Looks like daylight just because there's a full moon illuminating the observatory buildings, which are white, and illuminating the grass in the foreground as well. As well as putting these together into star trails, you can, if you wish, again, ignore the dots, they're nothing to do with the stars. The stars themselves are streaking because here it's effectively a video showing the stars rotating over a period of a few hours. If you want to get star trails, or if you want a video of the stars moving, fine. You don't need any specialist equipment at all. Just put it on a tripod or put it somewhere safe and then take a whole load of images. But if you want to take an image where a star comes out as a point of light, not a streak, then as the Earth rotates, you have to rotate the camera in the opposite direction. In other words, you need the camera mounted on basically a motor in a box. These things are called star trackers. You don't need a telescope. You can get some wonderful images with, there's my camera, a Nikon DSLR. It doesn't really matter what type of camera. It doesn't have to be a digital SLR camera. Pretty much any camera will do. But I have often taken pictures with my camera without using a telescope, and you can get lovely images of colorful nebula or the Milky Way, or that's a star that's blown itself apart. It went supernova a long time ago, and that's the wreckage of the star. There's our familiar Andromeda galaxy. Yes, if you want to buy a telescope and take images with that telescope, you can produce some wonderful images, and amateurs have been doing that for years, if not decades. But I warn you, it will take time. It will take effort, and it will take cash if you want to buy yourself a decent telescope and do astrophotography. My point is, you do not need to do that. You can get wonderful images by putting a camera on what I call a motor in a box. I built myself a so-called tracker. You don't have to go out and buy one. I built myself one. This is a DIY tracker. It's basically a couple of bits of aluminium, a couple of hinges, a couple of Duracell batteries, a little motor on the bottom, and it's designed that the top simply hinges upwards relative to the bottom, and I've designed it so it operates and rotates at the equivalent of 1 rotation per day. Doesn't actually travel very far, it only travels for about 15 minutes, but if you put a camera on the top here and switch it on, basically it will compensate for the rotation of the Earth. If you don't fancy building one yourself, if anybody does want to build one, email me and I'll tell you how. I've got the instructions for how you build this. It'll cost you about 10 or 20 quid or something like that. If you prefer, you can go out and buy one. Basically, a motor in a box. That's what sky trackers are, star trackers. Doesn't matter how sophisticated the manufacturer tries to sell you, it's basically a motor in a box. The motor is designed to turn at the same speed as the Earth, and as long as you're lined up with the Earth's axis, mounting a camera on the front, no matter how the Earth turns, the camera will turn in the opposite direction and effectively stay static as the Earth turns underneath it. So you might pay £100 or more for a motor in a box, or you can build yourself one, but the point is, you can take lovely images of the night sky without spending huge amounts of money. I don't know, you're a rambling club, maybe you're already interested in photography, maybe you already have cameras. If you already are using a camera, the chances are you can take wonderful images without having to invest huge amounts of money in telescopes, and yet you can still produce images of nice colorful nebulae and galaxies far, far away. So bear in mind that one of my favorite ways of passing time, I can't afford to do it very often, but one of my favorite ways of spending time is because I like wildlife photography. My friends and I have occasionally been to, for instance, Kenya in East Africa. That way we can combine our interests in looking at wildlife if we take binoculars with us. We also can do some astronomy with the same set of binoculars. And if we take a camera with us, then not only can we photograph the wildlife, but we can photograph the sky as well. So safaris are a wonderful way of combining all three of my interests that I've had a passion in for quite a long time. The mantra, I guess, is, well, you can take images and photos of animals by day, and you can take photographs of the stars by night. Sleep when you get home. There's no point in wasting time on holiday. You may as well use the time that you have available. Safaris, if you go to the middle of nowhere, not only can you see the wildlife of whatever the country you decide to visit, but the chances are you're going to get away from the cities. If it's a wildlife type safari, you're not going to be based in a city, you're going to be based in the middle of nowhere, you're going to be away from light pollution. In the various places I've visited in Kenya, the nearest street light might have been 100 miles away, for instance, and therefore you get wonderful views of the sky. It is possible to photograph the night sky, even with a little bit of light pollution. Again, if anybody's interested, if anybody says, I can't possibly photograph the night sky because the street lights are too close, again, email me and I'll tell you how it's possible to do that. But the bottom line is, the night sky is a wondrous thing. I hope we will be able to see the night sky for many decades to come. If certain individuals don't end up launching so many satellites, we find it impossible to see the sky anymore. So I hope you've enjoyed that ramble through the night sky. Thank you.